Hello students, in this video we are going to solve some KSET questions. The first question is the eigenvectors of the matrix 0, 1, minus 1, 0 are. The first option is 1, 0 and 0 minus 1, I 0, 0 minus I, 1 I and 1 minus I, and 1 0 and minus 1 0. So let us consider the given matrix as A is equals to 0, 1, minus 1, 0. We know that the characteristic equation is A minus lambda I is equals to 0. That is determinant of A minus lambda is equals to 0. So considering the characteristic equation of this matrix, we get 0 minus. So simply to get this determinant, simply we have to add the lambda to this diagonal elements, that is 0 minus lambda I. We get 0 minus lambda is minus lambda I, 1 minus 1 and minus lambda is equals to 0. So expanding this determinant, we get lambda into lambda is equals to lambda square, that is minus lambda into minus lambda is equals to, we get minus lambda square, minus 1 into 1 is equals to, we get plus 1 equals to 0. So that the lambda value is equals to, that is lambda square is equals to minus 1, or lambda value is equals to, we can write it as root of minus 1, which is equals to plus or minus I. Okay. So therefore the eigenvalues are plus I and minus I. Now we have to find the eigenvectors corresponding to these two eigenvalues. Okay, let x is equals to x comma y, or x is equals to x y column matrix as set of eigenvectors. Okay, eigenvectors. Now the properties of eigenvectors, we can write that is matrix A minus lambda I into x equals to 0. That is, we have this already, A minus lambda I, that is minus lambda 1 minus 1 minus lambda into x is equals to, that is xy is equals to 0 is nothing but our 0 matrix. Okay, now simplifying this one, we get minus, so simply we have to multiply these two matrices, that is first row into first column, minus lambda into x plus 1 into y equals to 0, and the second one is minus x minus y is equals to 0. Now the eigenvector corresponding to lambda is equals to plus I is, simply we have to substitute lambda value, so this will be minus lambda into y. So we have to substitute lambda value in these equations, so that this system of equation 1 becomes minus I into x plus y equals to 0, and minus x minus lambda is again y is iy is equals to 0. So consider any one of this equation, you will get the same result. So just considering first one, we get minus ix plus y is equals to 0, or it can be written as x is equals to, ix is equals to y, or simply we can write it as x divided by 1 is equals to y divided by I is equals to k, so that we get the set of eigenvectors are xy is equals to 1 I. Okay, or simply we can write it as this as x is equals to, we get 1 into k, y is equals to I into k. In particular, if you put k is equals to 1, we get set of eigenvectors is equals to xy is equals to 1 into I, 1 and I. So this is first set of vector. So now we got first set of eigenvectors. Similarly, we can find the second set of eigenvectors by substituting this lambda is equals to minus iy and continue the same procedure. But as you see in the options, it is the first set of eigenvectors is present in the third option and nowhere. So therefore, definitely the third option will be the correct, and the second set of eigenvectors will be 1 and minus 1 minus I. So by using the same procedure, you can find the second set also. Thank you.